I like this song. I wonder what it's called though. Let me just Shazam it. Wait a second. How does Shazam even work? The first thing to understand is that sound is a wave. When music plays, the air pressure around you is changing incredibly fast. A microphone measures those changes and turns them into numbers. So, to a computer, a song is not a melody. It is a long list of values changing over time. This is called a waveform. And at first you might think, perfect, just compare this waveform to every other song in the database. But there's a big problem. Raw waveforms are extremely fragile. If the song is quieter, the wave changes. If there's any background noise, the wave changes. If your phone microphone records it slightly different, the wave changes. The same song can have different looking waveforms depending on how and where you record it. So Shazam style systems need a representation that survives noise. They need to know not just what does the wave look like, but what frequencies are inside of it. That is where the Fourier transform comes in. A Fourier transform takes a complicated sound wave and asks which simple frequencies are hiding inside of this. Think of it like separating a smoothie back into its ingredients. The original sound might look messy, but underneath it, there's bass frequencies, vocal frequencies, drum hits, guitar notes, and harmonics, all mixed together. The Fourier transform tells us exactly how much each frequency is present. So, instead of only seeing sound over time, we can now see sound as a mixture of frequencies, and that is a huge upgrade. But still, music changes constantly. A song does not always have the same frequencies from beginning to end. So, the algorithm slices the audio into tiny time windows. For each slice, it uses the Fourier transform to find the frequencies present at that moment. When we stack all those slices together, we get a spectrogram. A spectrogram is like an image of sound. The horizontal axis is time, and the vertical axis is frequency, and the brightness shows how strong each frequency is. This is the moment where sound becomes visual. The song has turned into a map. Now, Shazam does not need every pixel of this spectrogram. That would be way too much information. Instead, it looks for the strongest, most distinctive points. These are called frequency peaks, moments where a certain frequency is unusually strong. A drum hit might create a peak, a vocal note might create another, a guitar chord might create several at once. The key is that these peaks tend to survive even when the recording is noisy. Background noises may blur the detail, but the strongest peaks often remain. So, the algorithm focuses on the parts of the song that are hardest to erase. Now comes the clever part. The app does not just store individual peaks, it stores relationships between peaks. For example, this peak happened at this frequency, and shortly after, another peak happened at that frequency. The time gap between them matters, the frequency pair matters. Together, those relationships create a fingerprint. Not a fingerprint like your finger, more like a mathematical, compact signature of the song. It is small enough to search quickly, but specific enough so that two different songs are highly unlikely to produce the same pattern. When you Shazam a song, your phone creates a fingerprint from the audio around you. Then, that fingerprint is compared against a database of fingerprints from millions of songs. The winning song is not the one with the lucky match. It is the one with many matching peak relationships that all line up in time. That time alignment is extremely important. If enough fingerprints point to the same song at the same moment in the track, the app can say, this is almost certainly the right song. And that is how it can recognize music from just a few seconds of play. So, Shazam is not listening to music the way we do. It doesn't think about lyrics, emotion, or whether the melody is catchy. It only does one thing. It turns music into math. So, to go over what we learned, a sound wave becomes frequencies. Those frequencies then become a spectrogram. The strongest peaks from that spectrogram become the fingerprint of the song, and that fingerprint gets matched against a database to determine exactly what song is yours. So, next time your phone identifies a song in 3 seconds, remember, it's not magic, it's signal processing. And honestly, that might be even cooler. Thank you guys for watching this video to the end. Hope you enjoyed, and make sure to like and subscribe. Thank you.